Good evening. I myself Pramod Kumar Thaplia, PGT Physics from KVB Airport. And the topic to our school is Thermodynamics of class 11th. Right? Thermodynamics. Thermo itself means in elementum heat and dynamics means in motion. Means here transfer of heat, right? Or you could say conversion of heat into mechanical work, mechanical energy you could say, and vice versa, right? So before going to that, we have some thermodynamics body. First of all, we will try to define. So what is thermodynamic body? Right? The body whose state can be represented in terms of pressure, volume, temperature, etc. The physical quantity we have there, right? Then that body is known as thermodynamic body. And this PVT, what we were saying, thermodynamic variables, right? In that we have pressure, volume, temperature, entropy, enthalpy, etc. Right? What about thermodynamic process then? Thermodynamic system, first of all. It is a closed system of, it is, you could say, collection of, instead of that we can say collection of large number of particles, atom or molecule you could say, depends, molecules under certain constants, right? Then after this thermodynamic process we have, thermodynamic system. Basically three types of thermodynamic systems are there. First one is open thermodynamic system. Means in which there is transfer of heat and the matter, right, all together. Second one is closed one, and third one is isolated one, isolated thermodynamic process. A simple example I can say, suppose I am having water in a container and we are providing heat to it. What will happen? It will convert into vapor. After 100 degrees Celsius, vapor will be formed. So what is happening? Transfer of heat is there as well as transfer of matter is there, right? Then it is known as open thermodynamic system. If I just close this with the help of piston, you could say, right, and I am supplying energy, so this is called closed one. And if it is such that it is also insulated from the base and piston is placed here, then it is called isolated one. Means neither the heat nor the matter will transfer. Here heat will transfer, right? The three basic type of thermodynamic system. Now, after this, the basic funda, we will use the word thermodynamic process. What is thermodynamic process? Now, thermodynamic processes. What is thermodynamic process? We were saying simply, if we take the basic variables P, V, T, right? Pressure, volume and change and temperature. Any change in these variables, any change under certain constants, limit is you could say constant, right, is known as a thermodynamic process. Means simply change in the variables of the thermodynamic body under certain constants is known as thermodynamic process. Then we come to the type of process. Types. We have got the first one is isothermal process. Second one is adiabatic. Third one, isobaric process. Fourth one, isochoric system. Right? And one more, fifth one, cyclic process. Right? Even in chemistry we do have that. So what is isothermal process? We will take one by one. So what isothermal process is saying, as its name make it clear, iso here it means equal or same. Thermal related to temperature. Right? If during a thermodynamic process, the temperature of the thermodynamic body remains constant, then the process is known as isothermal process. I can define it. If during a thermodynamic process, the absolute temperature of the thermodynamic body remains constant. Remember, throughout the process, other variables will vary, but temperature will remain constant. Then the process is known as thermodynamic process, right? Sorry, isothermal process. It is a very slow process. We want to maintain the temperature constant, right? So, if you do remember Boyle's law, the statement of Boyle's law is somewhere just like this only. What Boyle's law says that at a constant temperature, the pressure of a gas is inversely proportional to its volume at constant temperature. Right? Means this law will follow the isothermal process, or isothermal process is valid to this. So what we will get? We will get PV equal to constant for an isothermal process. Not only for Boyle's law, but for isothermal process it is also applicable. I can say P1 V1 is equal to P2 V2. We will discuss this at a length, but here we are just trying to define what we were having. right? So this is the isothermal process, a very slow process in which there is no change in the temperature of the body by keeping the temperature constant, right? Then we have the second one, then we have adiabatic process, a typical name, right? Adiabatic. In Hindi we used to say रुद्धोष्म, तो थोड़ा हिंदी से क्लियर हो सकता है, ऐसा ही कुछ लिखते थे रुद्धोष्म, लेकिन ये भी बहुत टफ वर्ड है, तो इससे भला इसमें ही है, मीन्स इसका सीधा अर्थ है नो एक्सचेंज ऑफ हीट एनर्जी, ऑफ हीट एनर्जी, no exchange of heat energy. It means it is a process in which there is no exchange of heat energy between the thermodynamic body and the surrounding. This process takes place so fast that there is no exchange of heat energy between the body and the surrounding, right? So this is known as adiabatic process. In it, heat supplied itself becomes zero, and for it the mathematical formula becomes, we will prove it later on, PV gamma equal to constant. For isothermal we have PV is equal to constant, here PV gamma is equal to constant, where gamma is ratio of specific heat Cp by a Cv, right, has got a fixed value. So this adiabatic can be expressed as P1 B1 gamma is equal to P2 B2 gamma. Other form will be there, we will express it later on when we use it in it as at length. So this is adiabatic. After adiabatic we have isobaric. One can have the value from itself, the meaning. Isobar is the unit of pressure, equal, here bar is the unit of pressure, right? Means if, it means simply during this process, what we have, the pressure of the thermodynamic body remains constant. This is isobaric. Then we have the fourth one, isochoric. Fourth, isochoric process, right? Iso again equal, and core word is used for volume, right? It simply says that during this process volume of the thermodynamic body remains same. In first one P was constant, here V is constant, like this, right? Isobaric. Then one more we did talk about is the cyclic one. Cyclic process, as its name make it clear. Cyclic means completing the round. If we are having a particular point in thermodynamic body here. This is the initial point and we are undergoing certain changes. But ultimately, if again we are reaching to the final one, right, then this is called cyclic. Change of variable will be there. Change in variables, thermodynamic variables, in such a way that the thermodynamic body reaches to its initial point, the point from which it starts and again reaches to the same point, then the process will be known as cyclic process. Work done during a thermodynamic process. Let us consider a thermodynamic body is at pressure P, volume V, right? And if I compress it, its volume becomes P minus P. Pressure will increase, P plus P, and volume will become P minus del V. Same way we can increase the volume also. So how to calculate the work done, right? The small amount of work done to change the volume by delta V. So what will be dW? Yeah, delta W I could say. Delta W. Generally we have force into displacement, right? अब यहाँ तो force है ही नहीं. For what we have as pressure is force per unit area, right? So force will become P into A, right? So delta W will be P into A into change, right? By what distance it has moved up, let it be delta x. So I am writing A delta x. So what this delta A delta x will give you, let it be like this, I can represent here. That will give you delta V. So this will become delta W will be P delta V, right? If it is compressed, for compression, naturally volume will reduce, dW will be minus P dV, P delta V. For expansion, right, it will be dW will be plus P delta V, right? And in terms of small change in volume, what we can do in mathematics, dW can be written as P dV, right? This is how we calculate by using calculus method. Total work done, I can say integral from V initial to V final P dV. That's how we do it. And it comes out to be, W comes out to be P V final minus V initial. That's how it is calculated, work done, right? Then we have internal energy. Represented by capital U. In thermodynamics, internal energy is the sum of kinetic energy and the potential energy of that thermodynamic system, right? But practically this U is always a function of absolute temperature. Internal energy of a thermodynamic body is a function of its temperature. So whatever changes will be there, the same temperature will be in terms of internal energy. After this, we start with laws of thermodynamics. The first law we will talk is the 0th law of thermodynamics. Law of thermodynamic, right? zeroth law. So what this law says, right? So according to this law, if two or more than two thermodynamic body are kept in contact inside an insulated system, then they both acquires a constant temperature. Simple, right? Under all equilibriums, it is like that. All will get the same temperature, right? It is just the, you can say, the law which we have read, or we will have it later on. Heat given is equal to heat taken. If a higher body is giving energy, the lower will absorb it. So this is zeroth law, right? But our main concern here, first law of thermodynamics. In chemistry, you might have read, they simply talk about the law of conservation of energy is the first law of thermodynamics. But is it so? In terms of chemistry, your chemistry teacher might have taught you that the energy can neither be created nor be destroyed, but it can simply be changed from one form of energy into another, right? But in physics, it is not like that. This law does follow the law of conservation of energy, but it is not just that statement. Suppose I am supplying a small amount of heat dQ, small heat energy, right? And dW be the small amount of work done. And du be the small change in internal energy. Just to learn this particular law, here just make it clear. Simple thing is slapping. While slapping, what we have to do? If I am having some energy in my hand, I am having some energy. First work will be to bring this hand up to the face, up to that body, this face. For that we have to do some work, and remaining energy will change the internal energy of this face, right? Slapping is the best example of first law of thermodynamics. So in physics, what this law says, if a small amount of heat energy is given to a thermodynamic body, then a part of it is used to do some work on the system or by the system, depends. Right? A remaining part of that energy will change the internal energy. Simple. Mathematically, dq is what? dw plus du. Right? Suppose I am having 50 joule in my hand. At least 30 joule will be used to bring the hand up to that target, and 20 joule will be change the temperature of that target. Right? So that is just it is in accordance to the first law of conservation of energy, but the statement is totally different. Right? So this law I can write in here does satisfy the law of conservation of energy. Right? So what we got according to first law of thermodynamics, if higher amount is given, I can write down Q plus W delta U. Remember, where Q is what? Heat energy supplied, given. Right? W, we have just calculated it, P dV. Delta U will be a function of temperature. Right? This is the first law of thermodynamics. Now, how to apply this law on different process? Right? Suppose I am having the first process, isothermal process. What was happening there? In isothermal process, the T remains constant, isn't it? T remains constant means there will be no change in temperature. Right? And we were saying internal energy is a function of temperature. Right? If T remains constant means what will happen here? Internal energy will also remain constant. What does it mean? If U is fixed, delta U is fixed, right? U is constant, the delta U will become 0. So, according to first law, what we have? We have Q equal to W plus delta U, means Q equal to W only. What does it mean? It means in isothermal process, whatever heat energy we are supplying, that will be used to do some work on the system or by the system. There will be no change in the internal energy. Right? That's why we say that is a very slow process in order to maintain that constant. Right? So in isothermal process, the first law of thermodynamics remains Q equal to W. Whatever heat is given, that is used to do some work. Now, same way for adiabatic. How to apply first law of thermodynamics for adiabatic process? Adiabatic. In adiabatic process, what we were saying, there is no exchange of heat. Q equal to 0 means no exchange of heat energy between the thermodynamic body and the surrounding. What we have according to first law, we were having Q equal to W plus delta U. So this is 0. W plus delta U, or it comes out to be delta I, W is equal to minus delta U. Right? What does it mean? It means In adiabatic process, work is done at the cost of internal energy of the thermodynamic body. If you have seen that punctured air, if your football get punctured and just check that air, it is always cool. Why? Because just to bring out that air outside from the football, work will be done at the cost of that air itself. That's why the temperature decreases. This is adiabatic. Then third one, isobaric. In isobaric process, what we have? P is constant, and according to first law, what we have? Q equal to W plus delta U. Q is equal to P delta V plus delta U. Means in this process, first law of thermodynamics will act as it is. Q equal to P delta V plus delta U. Isochoric. In isochoric, volume is constant. Volume is constant means change in, what will the change in volume? 0. And according to first law of thermodynamics, what we were having? Q equal to P plus P delta V plus du. Delta V is 0. So here Q equal to du. Means here whatever heat is given, that will change the internal energy. That is the 4 type of process and how we apply first law of thermodynamics on them. And later on we will talk about other things. Alright, thank you.